Hey team, so this video is about slope. I'm sure you guys have heard that word before when we talk about it in algebra. Essentially, we're describing how steep a line is when we graph it, okay? And another way to think about slope is it's a rate of change. And so when we look at this formula for slope, all right, m is our variable that we use to represent slope. So this says slope equals rise over run. So it's the change in y values over the change in x values. How much do we go up per every unit that we go over? All right, and the way we calculate that, and this is kind of the formula you need to know, the slope formula. Kind of like when those football players say they're from the Ohio State University, this is the slope formula. All right, we got to know this one, we got to know it well. All right, so the slope formula is y2 minus y1 over x2 minus x1. Means you take the y coordinates and you subtract them, and on the bottom you take the x coordinates in the same order and you subtract them. Okay, we get four types of slope: positive, negative, zero, and undefined. And when we think of this, we always are thinking left to right. Left to right. So when we deal with a positive slope, that means the line is going upwards from left to right. A negative slope is going in a downward direction from left to right. Zero slope means we don't go up or down. So from left to right, if we don't go up or down, we get a horizontal line. Zero slope is a horizontal line. And then undefined, right? Well, undefined means it's vertical. And the reason it's undefined is because it doesn't go left and right at all. So the change in x is zero. We don't go left, we don't go right. It only goes straight up and down. And so if the change in x is zero, you divide by zero, that's undefined. You can't divide by zero, you black out. Okay, so those are the four types of slopes. Now let's practice. So if I give you 2 points, we're going to be able to find the slope from those 2 points using our slope formula. So let's rewrite that slope formula. It's m equals y2 minus y1 over x2 minus x1. All right, and for some people, it can be really helpful to label the points. So remember that when you have a point, it goes x comma y. So if I have 2 points, this first one is x1, y1, and then this one is x2, y2. So if I'm going to do my slope formula, I'll go m equals y2 is negative 5 minus y1 is negative 9. Notice I had to use parentheses there because it's minus a negative, over x2, negative 5, minus x1 is 3. So on the top, this becomes a big plus. And it's negative 5 plus 9, which is 4, over negative 8. And that slope is negative 1/2 when you reduce the fraction. Okay. Then in the second problem, I'll do m equals, again, I'm going to subtract my y's. So we'll do x1, y1, and x2, y2. And when I subtract the y's, I get negative 2 minus negative 2 over 6 minus 3, x2 minus x1, 6 minus 3. On the top, that's negative 2 plus 2 over 3, which is 0 over 3. And if you have 0 on top, the answer is just 0. 0 divided by anything is just 0. Okay, let's do, so that's the slope from 2 points. If I give you 2 points, you can calculate the slope. What about if I do slope from a table? All right, so from a table here, I've got x values and y values. So I can pick any 2 pairs to make them x1 and x2 and y1 and y2. So let's just do this. This is y1 and y2. This is x1 and x2. You get to pick. But because these are both x's on top, those are x's, these are y's, that's x1 and x2, y1 and y2. You could have picked any 2 pairs of numbers you wanted. So when I do this, I'll do m equals, I subtract y2 minus y1, 5 minus negative 7. over x2 minus x1, 6 minus 3. And I get 12 over 3, which is 4. So my slope there is 4. All right, 2 quick application problems. So slope representing a rate of change, slope is a rate of change. Well, there's a lot of rate of changes that you know in the real world, such as miles per hour. Your speed is a rate of change, okay? So here's another example. This table shows the cost of using a computer at an internet cafe for a given amount of time, all right? Find the rate of change in cost with respect to time. So if I look at my units, I can see that my rate of change is going to be dollars per hour, because I need to think, if in a table, the top is x and the bottom is y. So if I'm doing change of y over change of x, I would get dollars per hour. Okay, so to do that, we're going to treat this the same way. So this is y1 and y2. This is x1 and x2. Okay, and so let's do my slope again. M equals 14 minus 7 over 4 minus 2, which is 7 over 2. Right? Now, if I think of this is $7, because this has a word problem, so these have units. $7 per 2 hours. All right, so my rate of change is 7 over 2 dollars per hour. Dollars per hour. But usually when we do a real world problem, I want to know not how many dollars 2 hours is, I want to know how many dollars 1 hour is. So that's when I find the unit rate of change, which means I just try to make the denominator 1. And the easy way to do that is to actually just divide this and get a decimal. Okay, so 7 over 2 and then is equal to 3.5, and now I use dollars per hour. Okay, so this is $3.5 per 1 hour. If I wanted, I could put that over 1, and it'd be $3.5 per 1 hour, and that's what makes it a unit rate of change, because unit means 1. So my unit rate of change is, and you could even, if you want, write it with a dollar sign, $3.50 per hour. That's a lot more helpful or like understandable than 7 over $2 per hour. All right, that we don't know, we don't understand that as well. So the unit rate can be really helpful. So let's do one more application problem. Application number 2 here, the graph shows the height above the ground of a rock climber over time. So if we find the slope, right, I just need to think about my formula again. M equals y2 minus y1 over x2 minus x1. And I have 2 points on the graph, so I can call those my x1, y1, x1, y1, and this one would be x2, y2. Doesn't matter which you make 1 and which you make 2 as long as they're paired up correctly. Okay, then when I'm doing my math here, it would be 0 minus 26 for the y's over 8 minus 0 for the x's, which is negative 26 over 8. And that is a reduce, if I divide those both in half, that's negative 13, negative 13 over 4. So that's my slope, negative 13 over 4. And that makes sense. Do you notice this is a slope going downward from left to right, so that's a negative slope. But if I want it as a rate of change, right, I need to think about the units. Well, the y units always go on top. So y units go on top, that's meters per second, because time is in second, x is on the bottom. So if I divide this out, I'm going to get negative 4, 8, 12, so that's 3.25. You could use a calculator if you needed, but 4 goes into 13 3 times with 1 left over, so 3.25 meters per second. That's the slope as a rate of change. Okay, We'll get some more practice with these tomorrow. Have a nice day.